Hello and good morning. My name is Chad Jenkins. I am a technical artist at Squad, and I work on a game called Kerbal Space Program. So this is Squad with our awesome monkey logo. And here is Kerbal Space Program. So has anyone here actually played the game at all? Hey. Awesome. Okay. So for those who don't know, what is Kerbal Space Program? Okay. So it's kind of a rocket-powered building kit in Sandbox. So you have these little modular parts that you put together, and you use them to build rockets, and that is a lot of fun. So it's got a full orbital simulation. There's physics and an entire solar system. So every planet that is there you can actually go to. You can get out, you can walk around, drive over it, things like that. It's also a space agency simulation. So on that aspect, we actually have a career mode that we're working on. The game is early access, so it's actually still in development right now. So everything I'm talking about is kind of, in some ways, a work in progress as well. But we're going to be adding, we've got science in there already, and we're going to be adding missions and sort of a contract system as well. So you can build pretty much anything. You can build rockets, aircraft, things like rovers. You can also build whatever this thing is, which is a fun, crazy amalgamation. You can build orbital frigates. Why not? And people just go to town with it. So we're going to talk a little bit about the early days of KSP. This is when we first released to the public. The game was very rapidly developed. Squad was originally a marketing company, and the game was in some ways kind of an experiment. So we were not really sure if it would succeed or not, and really the next update could have been the last. So we didn't really do a lot of planning ahead in that case. We just tried to get everything in there. Hey, does this work? And go from there. So there was a lot of leftover code from when we were doing our prototypes. And in KSP, everything is built out of these little parts. So here's some of them. We've got a couple different engines. There's 3 right there. That little ring is used to give torque so you can control your pod. And we've got the command pod itself. And everything in the game, these parts were actually, one part was one script. You could change the visual model out, but the logic was a specific C# script. So everything in KSP is programmed in Unity, and we use C# for it. So you can see that just for these 5 parts, we actually had 5 different scripts. So for example, here is what, kind of in an abstract way, our engine types look like. So you can see here, this is a liquid rocket engine. It has some code in there for control, some to actually contain how the liquid fuel flows through the rocket. So that was actually part of the rocket's logic itself. And it had a little bit to determine how it actually thrusted and performed in the game, the physics and things like that. And when we did a solid rocket engine, the difference between this one is that it's going to be its own internal fuel supply. You can't flow the tanks or anything, and it had a time limit. So basically, it would burn, and then when it ran out of fuel, it was done. So you can see the control is a little bit simpler. We removed a lot of the fuel code from the other one, but more or less this is just kind of like a copy-paste. It's derivative from the original liquid rocket. And with the jet engines, we had a similar situation, but they ended up being a lot more complicated in the fuel because they need to have atmospheric oxygen in order to work. They need to stop working when you leave the atmosphere or on a planet that doesn't have it. So you can see here we had a lot of copied code. And this worked well on a small scale. And was really kind of carried over from the prototypes that we had of the game. And you're saying, well, this doesn't sound too bad. What's the problem? Well, it was actually really hard to iterate on the system. There was no easy way to add behavior to all engines, for instance, because each one of them was a dedicated script. And we had to copy-paste any upgrades. So if I made an upgrade to how the engines worked or how we calculated masses for the fuel, we had to go ahead and copy-paste that everywhere. And it ended up being kind of very rigid. You could only have one script, and you couldn't have anything that had like multiple subscripts. Because in KSP, since modding's been very important since the very beginning of the game, everything is loaded at runtime, and it was kind of very rigid in that way. And it ended up being a lot of duplicated code, which really ended up being a problem. So then there were the bugs. And if you've ever seen this one before, it's kind of summing up how we felt, You had 99 little bugs in the code, 99 little bugs in the code. You take one down, you pass it around. You have 117 little bugs in the code. So, and the issue was, where was the problem? If you had a problem with the fuel flow, it could be anywhere, and we had to fix it everywhere, which was unfortunately an important bit. So if you missed like one file or missed one area, you would still have the bug, and it became really hard to track down where the issue was actually coming from. So as the game became more successful, the pace of development really started picking up. The old system became kind of completely untenable to maintain. We had more people coming in the project to help out. So where do we go from here? What was the solution? So we took a really bold move. All credit to Felipe, who is our lead designer. He basically approved this and thought it was a good idea as well. But we kind of threw out everything we had, and we did this while the game was very much still alive. It was released to the public at the time as we're working on trying to redo this design and deprecate our old code. But we really wanted to have rapid iteration. We wanted to make sure it was easily debugged. We wanted it to be upgradable and highly flexible. And we also wanted it to be very easy for modders and people to actually edit. So how did we do it? What did we do from there? Well, we focused on breaking down all of our complex systems into smaller chunks. So for instance, our parts, which is a discrete object that you can place in the game, we broke it down to just a visual model, its base attachment logic, physics, how destruction and persistence is handled. So it became, in essence, just a container or a blank slate. And importantly, it had a list of modules, which is the code that we would attach to it. So here's, for example, how we started cutting up one of them. The engines were one of the more complicated parts in the game, so I'm using that as the example here. So we cut it up into discrete behaviors that we called modules. The control, for instance, we actually took out the control, which is kind of the bare minimum you needed in order to run an engine. We removed all the fancy stuff that they could do, like the nozzles actually rotating, because that's not really a function of being an engine. And we also took how thrust is calculated, because the equations for that are very much solid, and they're the same no matter what kind of engine is producing the thrust. So we abstracted that as well. And we also took the gimbal, which is how the nozzles rotate and how they control. We moved that into its own module. And we moved all of the fuel code into something that we call the resources system. And I'm going to go into that a little bit more in a few slides here. But the resources system actually took control of all of the fuel flow, all the fuel logic. And that way it wasn't actually part of the engine. So we didn't have 3 or 4 different versions of how fuel flows around your ship in different places. So we also took things like our special effects, things like the heat animation, jettisoning, the actual coverings of the engine, and we put those into modules as well. Because, again, they weren't really part of what was necessary to be an engine. Okay. All right. So here is our old friend, the liquid rocket engine from earlier. You can see here now it has its engine module, which handles all of its controls. It's got all of its variables that people can edit at runtime. The jettison module, heat, animation, and gimbal. And here's our resources system. Now, the resources system was a name, and it had a property, which is really just the density. So if you had 100 units of it, it would multiply by the density, and you end up getting the mass. And it was all done by the system, so you could edit it, and you don't have to worry about editing the weight or worrying about the persistence of the weight or anything like that. It's all handled by this one system. So if we had an issue with it, we had a central location to go to debug it and to fix it. And for instance, a fuel tank suddenly just became a storage for resources. So you just put the number of resources that's in there, and it handles pretty much all of it for itself. And the cool thing is that it's just done by name. We actually key it by name, and then we hash it, so it's a little bit faster to get it. But you can name it anything. If you wanted your engine to run off of anything, tuna or sunshine or something, you could. And as far as the names go, as long as they matched, it would be no issue whatsoever. So the system's very easy to mod in that regard. So people were able to add new fuel types very quickly. So this is actually what the resources definition looks like. You can see here it's actually just a text file. And our game will go through and it runs through all the different folders, looks at the text files, and we assemble everything into a database. So we have the game database here, and it'll list the name. So this is very easy to edit. It's not actually code. We just put it in blocks, so it's nice and arranged. You put the name of it. You set its density, the flow modes, whether or not it can flow through the ship and how it does that. And transfer is if you can pump it from one place to another. So you can see the liquid fuel that the liquid rocket engines use. It's all just this simple resource definition. If you come down to the solid fuel, down there you'll see that we do the same thing, it's just a different name. Mass is a little bit different per unit. And it can't flow anywhere. So you can't flow, you can't transfer, it's just a solid block of fuel. So it was really easy now to make the solid rocket engine. It's not a separate script. We just take that text file, that part definition that we have, we put a engine module in there, one for the heat, and then we actually just added a definition for a resource, the fuel that it needs, and since it can't flow, it will only ever look to itself. So a lot of the complicated behavior of how a solid rocket engine works now just became kind of a function of just combining the modules in different ways. And all of that just goes through the resource system so it can request its fuel. If it gets it, if it doesn't, once it runs out, it'll automatically shut down. It's basically everything that we wanted to happen, and most of it's just happening kind of as a function of the system, not something we've explicitly coded. And the same really goes for our air-breathing engines. These are the jet engines that we used. So we did the same thing. It's got an engine module, just like the other ones. And it goes through our resource system. But we added a new module which can create resources. So all we're doing is creating a named resource, in this case, air. And that module is checking whether or not, all right, am I in the atmosphere? Does this planet have oxygen? Things like that. But the thing is, the jet engine doesn't care about any of that. It really doesn't matter. It just wants to know, do I have the resources I need to operate? And once you actually got high enough into the atmosphere, the resource module would stop producing resources, and then your engine would flame out, and you'd go into a spiraling, crash into the ground. Be very bad. And it also used liquid fuel, and those were just standard definitions where you contained a resource. So what does that actually look like? So we have these files called part.cfgs. You can just put them in a folder to keep things organized, and it has the visual model for your part in there. So one of the modules here, the jettison one, it's just looking for a named game object in Unity that it latches onto. So it really doesn't care what's going on with the rest of the engine. It just finds that thing, and once you actually jettison it, it just throws it away, and it remembers that that object was separated. We have the heat module there. That one's very simple. You just put the name of it and has an animation name that goes with it as well. And you can see here, we were able to produce things like an alternator where it actually generates resources. And the cool thing is it's just a list. So I could have it generate as many resources as I want. I can get as complicated as I want. But we just kept it simple, and it generates electric charge. So it was really cool because everything can be edited by a content designer. You didn't actually have to know any code. And that also means that our players and modders were able to edit it with no problem. You could just open up a text file, copy-paste modules, tweak the variables on them, and get completely new gameplay behavior. So the resource system really rocked, and it was one of the better ideas that we had when we were breaking things into modules, because now we wanted to add a full electricity simulation in some ways to the game. So the batteries, for instance, all we had to do is put a resource definition there, so they just store electric charge, and that's, again, just by name. And then the solar panels are adding a resource into the system, and that will automatically flow into any containers that are available, and any parts that require energy to work, like the reaction wheel here, which actually torques the ship, that one, it just requests a resource just like the engines do. So there's a lot of, it's a very uniform interface to access the resources. And a generator, all it was doing was taking one resource and converting it to another. So you could do something like liquid fuel and have an alternator and actually produce power, or you could have like nuclear fuel and have a reactor. And really, it's just changing the names, but it gives the players kind of the feeling that, it's a different system. And we really applied this design methodology to all aspects of the game. So we use this with our special effects system. Previously, you could only have kind of like one special effect, and the module or the code for the engine actually handled all the effects as well. What we did now is with, for instance, this is our Rapier engine, just kind of as an example. All it does is output a 0 to 1 floating point number, and it outputs it to the name of the FX that you've produced. So, for instance, running FX was the name of it. It's actually got particles, sound, For instance, the engine roar, the turbines, things like that, and the smoke that's produced for it. And each one of those little submodules is just an interface. So they all accept that 0 to 1 float, and each one of them just handles it on their own. And you can add new modules and just combine them. It's very much how we design the parts as well. So you're able to do this now with special effects, and you can just add them however you want. We also had the option to burst them, and all that did was just set it to 1 and allowed you to just kind of do like one off. So it just set it to 1 and it ended it right afterwards. And we used that for things like flame out when the engine ran out of fuel, throw out some sparks and do some cool explosion sounds. So for instance, this is the example of kind of how our FX were defined in the game. And you can see here the name of this one is just running closed, and that could be anything you wanted. As far as the part was concerned, you just filled in that name to link the FX to it. And you could have as many of these little sub-definitions as you want. So it's very much like a block format. And you can put in audio, you can put in particle effects, and just keep adding them. And it could be any length, any kind of complexity that you wanted. And the same thing applied if you look at volume. Every time that you used the keyword volume, it was actually adding keyframes. So it allowed you, with no code at all, externally to create animations. So it starts out at 0, and then it goes up to 1 as the engine power increases. So you could have really complicated FX, rising, falling, changing the sound modulation. In the case of the particles, you can change the emission as well to determine that it cuts off at a certain point when the engine's not running fast enough. And none of that was actually done hard-coded. You just did it through these module definitions right here. So the real benefit of it was that we had a central location for debugging. You only had the one module to check, and you were able to debug every single engine in the game, which became really important as the part count increased. And it was easy to upgrade a module. You had one place to go ahead and put that and attach it, and it would affect everything. And we were able to really rapidly iterate. So we were able to go ahead and try combining different modules, see how they work together, and if they didn't work very well or they had some issues, we could just make one little change to it and get them to work together as we wanted to. And it was really easy to mod. So just like we're using the same system to create new parts for the game, our modders are able to create parts for the game the same way. So they can create really complicated things. If you want an engine with a parachute in it, or you want engines that actually physically rotate, you just attach a module to it and it'll handle all that kind of as a side effect almost. And adding a single module was really nice, because if we added one piece of code, we can now attach it kind of everywhere, and we can use that to come up with even more combinations than we had before. So that was really fun as well. So we were able to really smoothly transition from having a really small number of parts. Here's an early screenshot of the game. You can see there's really I think maybe 15 parts at the time. And most of those were their own script, like the fuel tanks, everything was its own script. Now we have a repository of over 170, and they're all using this exact same system. And the number of mods that are out there are countless. We literally have thousands of mods. And you can see here some of the mods, they're very diverse. We've got one that does like an autopilot. We've got ones that add resources. So they've actually created a whole economy of mining these resources and processing them into different things. And those are just converting from one resource to another. And you can see here some of them have like 1.9 million views and a lot of downloads as well. So it's been very successful, and it's been really kind of embraced by the community. So it's been a really important part of KSP's development. And I just want to say thank you for listening. This is a team here at Squad, and thank you. What's that? Yes, there are mics here. So if we've got a few minutes left, if anybody has some questions, you can come up to the mics and ask.
Hey, so with soft data formats like text files...
I'm sorry, I can't hear you.
With soft data formats like text files, I often run into like consistency issues. I don't really know how to communicate that back to the moderators. Like, how did you guys sort of approach that?
Well, as you saw, we actually had these little blocks, and we arranged all the code into blocks and sub-blocks. So it made it kind of a very natural hierarchy. And they could see all of our configuration files. Like, these are all accessible for every single part in the game. You can just go into the directory and you can see these. So they had a lot of reference. and the modding community shared a lot of information, so they really didn't have any problems adapting the format and understanding how to use it. Okay, we have another question?
So when you have a system that allows for many mods to be created easily, it could reduce the importance of any single mod or any focus on a single mod. Could you comment on that a little bit?
Okay, so having a lot of mods, does that reduce the focus on a single mod? Well, really kind of the community sort of moderates the mods themselves. They kind of become popular organically, and it hasn't been really much of an issue. The really good mods kind of like float to the top. They get a big following. So I haven't really seen it as much of an issue.
Thanks.
Yeah, sure.
Hi there. Do you allow for any sort of logical scripting? What I'm seeing with your modules is mostly data scripting. You can modify data to generate new gameplay, but for more complex behaviors, is that something that requires code, or how does your community handle that? Okay.
So the question is about more complicated behavior and loading that instead of just doing data editing, more or less. Well, the nice thing about it is that we actually do runtime loading of DLLs. So a modder can actually create their own logic. They can create their own modules, and then those modules are often used by other modders. So they all end up being more pieces of the same kind of puzzle, and they can just combine them. It's like creating more building blocks. You can build more stuff with it. So it hasn't been an issue. And let's see.
Hi. I was wondering, can the users also add 3D assets to, on top of modding the module files that you showed us? Can they add a different kind of engine altogether that looks different, or change the place from which the particles are emitted?
Yeah. So you're asking if they can actually change the visual models and particles.
Exactly, yeah.
Yes, you can. I didn't have time to really go into that, but we applied the same approach to loading visual assets. We actually have a tool that you load up in the indie version of Unity, and it compiles the part. It can compile particle effects as well, and then you just link them. So in that effect definition, I had a name, and that name is actually the path to where that is stored. So you can really put it anywhere.
So basically, you make your own model, put it in Unity with your tool, and then you can just ingest it in the game.
Yeah, it's really nice because our game only loads one format, so we actually serialize the meshes. So you load in Blender, 3ds Max, whatever it is you want, and we just compile it into basically a binary stream that we load at runtime. So we only have to handle one format, and we leverage the power of Unity to be able to open pretty much anything under the sun.
Excellent.
Nice.
Thanks.
Okay. I think we have time for at least one more question.
Just following on from that question there, so does your tool also, how do you define the mounting points on the custom models that you put in, for Legoing them together?
Okay. So typically when I'm making a model, all I do is have an empty game object in Unity. And since we're exporting from Unity, the coordinate systems are one-to-one. So I just place it wherever I want. So just like a little visual helper. And once I get in the position, I can just copy the information from the transforms XYZ and then put that into the file, the part CFG that we have. And you can just edit them very easily that way. Okay. No problem. All right. So any more questions? I think that's it. And I believe I'm out of time. Thank you.